Welcome to this video on reaction rates. We will define reaction rate, explain how it is measured, and identify the factors that affect it. We'll also cover activation energy and interpret potential energy diagrams for chemical reactions. We are exploring how fast chemical reactions occur, the reaction rates. We'll understand the factors that influence reaction speed, look at the role of energy, and analyze reaction pathways using diagrams. The key concepts we will cover include the definition of reaction rate, influencing factors like concentration and temperature, and collision theory. We will also examine activation energy, rate laws, and reaction mechanisms. Reaction rate is defined as the change in concentration of reactants or products over time, usually measured in molarity per second. We can express it in terms of reactant disappearance or product appearance, and differentiate between average and instantaneous rates. Several factors affect reaction rates. Generally, higher concentration and temperature lead to faster rates. Catalysts increase the rate, as does increased surface area. The inherent nature of the reactants also plays a role. Collision theory states that reactions happen when particles collide with enough energy and the correct orientation. Effective collisions lead to product formation. Increased concentration or temperature leads to more effective collisions and faster rates. Activation energy, or EA, is the minimum energy reactants need to overcome to form products. Reactions with higher EA are generally slower. Catalysts work by lowering this activation energy barrier. Rate laws show the relationship between reaction rate and reactant concentrations. The rate constant, K, is the proportionality constant in the rate law. It is determined experimentally, and its units depend on the overall reaction order. Reaction mechanisms detail the sequence of elementary steps in a reaction. The rate-determining step is the slowest step, limiting the overall rate. Understanding mechanisms helps predict outcomes and optimize reaction conditions. To summarize, reaction rate is the speed of chemical change, influenced by factors like concentration, temperature, and catalysts. Collision theory explains the need for effective particle collisions. Activation energy is the essential energy barrier, and rate laws express the rate-concentration relationship. Consider these questions as key takeaways. How does temperature affect rate, and why? What is the role of a catalyst? What is activation energy? How are rate laws determined? And what is the significance of the rate-determining step?